Hello students, welcome back to SIP Rasayan. In this lecture, I am going to explain nomenclature of heterocyclic compounds. So what are heterocyclic compounds? If in any cyclic organic compound, there is at least one heteroatom. Heteroatom means atoms. Heteroatom means atom other than carbon. For example, nitrogen, sulfur, oxygen, etc. So if in any cyclic organic compound there is at least one heteroatom in the ring, it is called heterocyclic compound. So examples of some heterocyclic compounds are pyridine, furan, pyrrole, etc. Here you see 5-membered ring having 2 double bonds and carbon is substituted by oxygen. Here carbon is substituted by nitrogen. In benzene, here carbon is substituted by nitrogen. All those are examples of heterocyclic compounds. Now, commonly used nomenclature system for heterocycles are combination of systematic name and trivial name. Systematic nomenclature system is the most widely used system of nomenclature and it is used for 3 to 10 membered monocyclic heterocycles. Under this Hunt-Widman system, this system is accepted by IUPAC. This is accepted by IUPAC. We will study about this system. So now I am going to explain Hunt-Widman system. Now we will study about preferential order of prefixes for heteroatoms. For oxygen, you have to use prefix oxa. Mind it, it's oxa, not oxo. For sulfur, thia. For selenium, selena. For tellurium, tellura. For nitrogen, aza. For phosphorus, phospa. For arsenic, arsa. Antimony, stiba. For bismuth, bisma. For silicon, sila. For germanium, germa. For tin, stana. For lead, plumba. For boron, bora. For mercury, mercura. Preferential order means, suppose in your heterocyclic compound both oxygen and sulfur atoms are present, then when you will write the IUPAC name, for prefix first you have to mention for oxygen and then you have to mention for sulfur. So this is decreasing order of priority of heteroatom. You can write here as table A. In table B, we will learn stems means ring size for 3 to 10 membered heterocycles. For 3 means tri. Okay. You have to remember these 2 letters, just reverse it. IR. Then tetra. Just consider these 2 letters, ET. For hepta, 7 membered. 7 means hepta. Okay. Here, remember these 2 letters, EP. Octa. Remember these 2, OC. For nona, you remember this one, on. For deca, remember these 2 letters, EC. Now for 5 and 6 membered, remember for 5 membered all and for 6 membered remember in. So all those you have to remember. Now see, for 3 membered ring without nitrogen, for saturated heterocycles means if there is no multiple bond, you just take this one IR and there you have to add N, A-N-E. So it is irene, that stem you have to use. For 4 membered, ET is there, so it N, ethane. For 5 membered, just add there in all, you have to add A-N-E, olane. For 6 membered heterocycle having all those atoms, you have to add only A-N-E. But if 6-membered heterocycle is having all those atoms, nitrogen, silicon, germanium, tin, lead, then you have to take this in and then you have to add ANE. So mostly what we are doing, we are taking this and there we are adding ANE for saturated system. If your 6-membered heterocycle is having boron, phosphorus, arsenic, antimony, then also you take in and then add N. For 7-membered saturated system, take epane. Only here we are adding N. For 8-membered, octane. Similarly for 9-membered, on. For 9-membered on, there we are adding N, onane. And for 10-membered, here we are adding N, so it is ecane. Now for unsaturated system we will see. If you are having 3-membered ring with unsaturation and if nitrogen is present, take IR, there you have to add INE, irine. But if 3-membered ring is there with unsaturation and no nitrogen is present, you have to take IRENE, irene. So with nitrogen means unsaturated system irine and without nitrogen means irene. For 4-membered ring ET, there you have to add E only. For 5-membered ring ol, there you have to add E. For 6-membered ring having all those atoms, you have to add in, there you have to add E. Here also same thing. 6-membered ring having all those atoms, boron, phosphorus, arsenic, antimony, here you have to add INE, like this one. 7-membered ring with EP you have to add INE, epine. For 8-membered ring with OC you have to add INE, okine. For 9-membered ring we have to add with ON, we have to add INE, onine. And 10-membered ring with EC you have to add ine, so ekine. So mostly what we are doing for 3 and 7 to 10-membered ring, with this we are adding INE. And here for 4, 5, 6-membered ring with whatever it is there, we have to add only E. So remember, here we are using mostly INE, here we are using ANE and here we are using E. All those you have to study. Don't get confused. If you can do all those, you can remember these things. Naming for IUPAC, naming for heterocycles, you can do easily. Another thing you have to remember, for 3, 4, 5-membered ring having nitrogen, if you are having saturation, means if multiple bonds are not present, then 3-membered ring means IR. If nitrogen is present, we have to add there IDINE, iridine. Or 4-membered ring with nitrogen with ET, you have to add IDINE, etidine. And for 5-membered ring with nitrogen with ol, we have to add this one. It is called olidine. So iridine, etidine, olidine. So using these stems and whatever prefixes I gave, we have to write IUPAC name. Now see some points you have to remember. If the stem starts with vowel, the terminal letter A of the prefix is dropped. For example, if you are having this heterocyclic ring, for writing the naming, what we have to do? Sulfur means from table A we have seen thia. Plus, what stem we have to use for saturated 5-membered ring? Olane. it is written here, if the stem starts with vowel, it is starting with vowel AO. So terminal A of the prefix you have to drop. Means you have to drop this one. Thaya, it will become THI. You have to drop this A and it will be Olen. Means it is thiolane. So sulfur means thaya. We are dropping this A. If stem is starting with vowel. Now remember, if more than two different heteroatoms are present in any heterocycle, the prefixes are written in order in which they are in table A. If in a heterocyclic compound, two or more than two heteroatoms of the same type are present, they are indicated by di. If two are there, di. If three are there, tri. If four are there, tetra. Now see, with one carbon atom, if two double bonds are there, this system is called cumulative double bond. So unsaturated stems, you have to remember this point, unsaturated stems you have to apply only when there is maximum number of non-cumulative double bonds. Means suppose in four-membered ring, nitrogen is present, maximum number of non-cumulative double bond means here and here double bond should be there. Then only you can use unsaturated stems. Now we will do some examples how to write systematic nomenclature for heterocyclic compounds which are approved by IUPAC. So for this compound, three-membered ring with one oxygen. For oxygen, prefix according to table A, oxi you have to write, plus stem and suffix, what you have to write, three-membered ring with saturation means ene. It is starting with vowel, so you have to drop this A. You have to drop this A, so it will become oxidane. Three-membered ring, in three-membered ring sulfur is there. Sulfur means thia. Prefix you have to add according to table A. According to table B, this part is according to table B. Three-membered ring with saturation means ene. It is starting with vowel, so A you have to drop. It is thyrane. Three-membered nitrogen containing ring, nitrogen means aza, plus saturated nitrogen containing ring you have to write iodine. So this A you have to drop, it will become aziridine. Now three-membered ring, with one unsaturation, maximum number of non-cumulative unsaturation is possible like this one. So nitrogen means aza plus irine, unsaturated three-membered nitrogen containing ring, irine. So this is from table A, this is from table B. You have to drop this A. It is coming azarine. So here if sulfur is there with unsaturation, sulfur means thia plus, for nitrogen, irine, for others 3-membered rings unsaturated you have to use irene. This A you have to drop, it is coming thydine. Now 4-membered ring with one oxygen. Oxygen means oxa plus saturated 4-membered ring ethane. It is vowel, so A you have to drop, it is coming oxetane. So in place of oxygen, if sulfur is there, for sulfur thia, saturated 4-membered ring ethane. So that A you have to drop since it is vowel. That stem with suffix is starting with E. So it is coming thydane. If here nitrogen is there, now you just note down, nitrogen is having valency 3. It is satisfied by these two bonds, so one hydrogen should be there. Don't forget to write this one. It is aza plus etidine. So you have to drop this A for saturated 4-membered ring from table B. So azitidine. In 5-membered ring, suppose one phosphorus atom is there with maximum number of non-cumulative double bond. So according to table A, phosphorus means phospha plus ol, unsaturated 5-membered ring. A you have to drop, so it is coming phosphol. So with proper understanding, if you can remember table A and table B, all those systematic name approved by IUPAC you can write. Now see, for 5-membered ring having oxygen, using table A and table B you can write its name as oxolane. This is for sulfur thiolane, and for nitrogen in saturated 5-membered ring you have to add this stem plus suffix, we are getting azolidine. 6-membered ring with nitrogen aza plus saturation is there, so enane, azinane. 6-membered ring with unsaturation having nitrogen aza plus ine, it is azine, but its trivial name is pyridine or pyridine. This trivial name pyridine is preferred by IUPAC more than this systematic name. So this one very important, you have to remember this is more accurate. So with 7-membered ring, 1, 2, 3, 4, 5, 6, 7. 7-membered ring with sulfur thia plus epane, thipane. 7-membered ring with maximum number of non-cumulative double bond. With oxygen we are getting, for oxygen we are getting oxa plus epine, it is oxypine. If here nitrogen is there with 7-membered ring, aza plus epine, azipine. When two or more atoms of the same type are present in the ring, how you will give the systematic name? First you have to start numbering from this heteroatom. Next heteroatom should get lowest number. So numbering from this side only you have to do. From this side, this oxygen will get 1, 2, 3, 4, number 4. So that is not correct. This is the correct one. So that position first you have to mention 1, 3 hyphen. 2 oxygen atoms are there, so di. Then oxygen means oxa plus 5-membered saturated ring means olane. You have to add this stem. Now this one you have to omit because it is starting with vowel. Stem is starting with vowel. So just drop A and it is coming 1,3-dioxolane. What's the systematic name? Here also for this compound, here also you have to do numbering 1 from this side only, 1, 2, 3 it should get. Next heteroatom should get lowest number. So this is 1,3 2 nitrogen atoms are there, di. If 3 nitrogen atoms are there, tri. 3 atoms are there means tri. So di. Nitrogen means aza. Plus 6-membered unsaturated ring with nitrogen. So you have to add this stem. It is starting with vowel, so this A you have to drop. We are getting 1,3-diazine. 1,3-diazine. But its trivial name is pyrimidine. And this is accepted by IUPAC. This is systematic name, but trivial name pyrimidine is getting preference. It is accepted by IUPAC. Now see, if 2 or more heteroatoms are present in the same ring, as for example in this heterocycle, 5-membered ring, it is having. So you have to start numbering from that heteroatom which is having highest priority. So between sulfur and nitrogen, according to table A, sulfur is having highest priority. So start numbering from here, and next heteroatom should get lowest number. So if from this side we are doing numbering, nitrogen will get 1, 2, 3, 4, number 4. But if we are doing numbering like this, nitrogen will get number 3. So this is preferred, this is correct one. Now since sulfur is having preference over nitrogen according to table A, so for sulfur, which prefix we have to use? Thia. For nitrogen we have to use aza. Then 5-membered ring with unsaturation means ol, O-L-E. Now from here, before this vowel A is there, you have to drop this A, and before this vowel A is there, you have to drop this. So actual name will come from here, it is coming thiazole. But at 1 and 3 positions, sulfur and nitrogen atoms are there respectively. So its name will be 1,3-thiazole. Clear? Now next, you know, trivial name of this heterocycle is pyridine. This is accepted by IUPAC. Now in pyridine skeleton, if here one ethyl group is there, then how to do numbering? Then substituent should get lowest position. Here substituent gets lowest position. So obviously from heteroatom we have to start numbering. Then if from this side we are doing numbering 1, 2, 3, 4, 5, 6, substituent is getting 6. But if from this side we are doing numbering, substituent will get number 2. That is more preferred one. So name is 2-ethyl pyridine. Next, Now here for two or more identical heteroatom in the same ring, what you have to do? You have to start numbering from this saturated nitrogen. This is saturated, this is unsaturated. So from saturated nitrogen we are doing numbering, and next atom, similar atom, here we are discussing about if in a ring two similar atoms are there. So next atom should get lowest number. So obviously numbering will be like this one. So its systematic name will be 1,3 hyphen 2 nitrogens are there, so diaza plus 5-membered unsaturated ring means ol. We have to drop this A. So it is coming 1,3-diazole. But this is systematic name. But trivial name is imidazole. And this trivial name is accepted by IUPAC. This is more accurate. This is also correct, but this is more accurate. This is systematic name. Now here two heteroatoms are there, but they are different. And you know oxygen is having preference over nitrogen according to table A. So which is having higher preference, higher priority, from that you have to start numbering, and next atom should get lowest number. So this is the numbering. Another thing I have to mention, if in this skeleton any substituent is present, then also you have to do numbering in this way. If heteroatom is present, it should get lower number. Here both heteroatom substituent is present, so heteroatom will get preference for lower numbering. Otherwise from this side if you are doing numbering, then substituent will get lower position, but first one is, this one is accepted. Heteroatom should get lower position. Now what's the name of this compound? At 1 and 3 position, atoms are there, heteroatoms are there. So oxygen means oxa plus aza plus 5-membered unsaturated ring means ol. So this is vowel, so that A we have to drop. This is vowel, so this A we have to drop. So it is coming 1,3-oxazole means oxazole. 1,3-oxazole. Since it is starting with vowel, that's why we are dropping this A. If this one is not starting with vowel, then don't need to drop this A. Here in this heterocycle, one sulfur atom and 2 nitrogen atoms are present. So you know sulfur is having higher priority than nitrogen. So start numbering from sulfur. Then next heteroatom should get lower number. So obviously from this side we have to do numbering. If we are doing from this side, then this nitrogen will get number 3 and this nitrogen will get number 5. That is not accepted. That is not correct. So at 1, 2 and 4, first which atom is there? Thia. Plus 2 nitrogen atoms are there. So diaza. Then 5-membered ring having unsaturation ol. So it is vowel, so that A we have to drop. This is not vowel, so that this A we don't need to drop. So its name will be, systematic name will be 1,2,4-thiazole. Now see, here this heterocyclic is having 6-membered ring with nitrogen, sulfur and 2 double bonds. This is also same thing. It is having nitrogen, sulfur, 6-membered ring and 2 double bonds. Now see, for heterocyclic ring with maximum number of non-cumulative double bond. Here maximum number of non-cumulative double bonds are there. Here also same thing. And here one saturated atom is there, this carbon, and here this nitrogen is saturated. If case is like that, for heterocyclic ring with maximum number of non-cumulative double bonds and a saturated atom, then how we will do systematic name? Both are isomers, So how you will specify that here saturation is there, here saturation is there. So skeleton, what is the name of this skeleton? Between sulfur and nitrogen, sulfur is having higher priority according to table A. So give numbering like this way. Then this next heteroatom should get lower number. So this is the numbering. So this is 1,4 hyphen thia plus aza plus 6-membered ring with unsaturation. You see, it is INE. So this is vowel, so that A we have to drop. This is vowel, this A we have to drop. So it is coming, skeleton is coming 1,4 thiazine. But how to mention at position 2 saturation is there. So here what you have to do, you have to mention at position 2 saturation, means one extra hydrogen is there. That one you have to write in italics like this way. And what's about this? Here same numbering you have to do, and at position 4 saturation is there. So here you have to write 4H italics 1,4 thiazine. This T is capital. Okay. This T is also capital. Now this is very important. You know pyridine skeleton, 6-membered ring, we did already. This is pyridine. Pyridine. Now in pyridine skeleton, at position 2 ketone is there. So pyridine 2-one. Since it is starting with vowel, so that E is dropped. And at one position hydrogen is there, means saturation is there. So we are mentioning that position 1H one. So systematic nomenclature system for Hans-Widman system is completed here. In next video we will do trivial name of some heterocyclic compound. Thank you for watching.